Okay, so let's do an example of finding the velocity and the acceleration when we have the expression for the path that a particle is taking while traveling. So a ball slides down the slope described by an equation y is equal 0.05 x squared meters. And we know that at x equals 5 meters, we have the velocity x and the acceleration in x direction. Our x and y. And we know that we have these parabolas that our ball is rolling down. And with 0.05 x squared. Since we have the velocity and the acceleration in x direction, we need to find the velocity and the acceleration. So those we know, we want to find the velocity and the acceleration in y-axis. And we have the position. So we know that the velocity in y will be the derivative of y respect to time. So that will be the derivative of that expression that we have here, 0.05 x squared, right? And then we know that x also depends on time. So we will have to use our chain rule and say that 0.05 is a constant. And then we have 2x. And then we derive the x respect to time. So actually we can write 0.05 times 2x times x dot. And what is the x dot? Actually the velocity that we are given. So we already know then that our velocity in y, which we can write it as y dot, will be 0.1 x times x dot. That's the expression for our velocity in y. What about the acceleration? Well, we know that the acceleration is the second derivative of the position or the derivative of our velocity. So the acceleration will be the second derivative of y respect to time, which is the same as deriving this expression that is right here, right? Or the first derivative of y dot. And we know here that we have two variables that depend on time, so we have to do 0.1, the derivative of the first term, times the second, plus the first times the derivative of the second. So that's the expression for our acceleration. And we have all these values. This will be x2 dot. So we know for x equals 5 meters, y dot will be that expression times 5 times the velocity, which is -3. That leads us to -1.5 meters over second as the velocity when x is equals 5 meters. The acceleration will be that expression evaluated in the data that was given. So that will be 0.1 times -3 squared plus 5 minus 1.5. And that gives us the result for the acceleration, which is equals to 0.15 meters over second squared. So those are the results of the components of the velocity and the acceleration of the ball at x equals 5 meters. The components, velocity and the acceleration in y directions, because the ones in x directions were already given.